Eastern Territory Manager for Techstar. The goal of the presentation today is to go over some pressure transmitter basics and show the benefits of the Yokogawa EJA or EJX pressure and DP transmitters. This is so that you will allow Techstar and Yokogawa to partner with you on all of your pressure needs in your facility. Before I dive into all things pressure, I would like to take a second and introduce any of you that are not familiar with Techstar to who we are and who we represent. Techstar is a manufacturer's representative for pressure, level, flow, temperature, machinery health, fixed gas detection, and a full product offering of analyzers and associated systems. We have an in-house telemetry group as well ready to give you a complete solution to your needs. We have been in business for over 20 years and have hundreds of years experience and combined industry experience. In this slide, you will see a list of our top manufacturers. To start with pressure, let's go with that there are 4 types of ways we measure pressure: gauge, absolute, vacuum, and differential, or DP. Today, we will be focusing mainly on gauge and DP, as that is the most widely used types we see. In North America, most capsules or ranges are based on inches of water column, PSIG, or PSIA absolute pressure. 27.68 inches of water column is equal to 1 PSIG. So it doesn't matter how big around your vessel is. All it matters is how tall it is. So in other words, if you're measuring level and you looked at the gauge pressure transmitter and it showed 2 PSIG, that's going to be equal to around 55.36 inches of level. Here are some examples of what Yokogawa transmitters look like. As you can see, they come in a few styles to mount up to whatever your old existing transmitter might be if you're replacing an older unit in your facility. And so actually I have right here an EJA 530 inline pressure transmitter, and behind me I have an EJA 110 DP transmitter and a 530 absolute transmitter. There are 3 sensor types for pressure. Those are capacitance, piezoresistive, and resonant silicone. Some companies use this capacitance or piezoresistive technologies when it comes to making their pressure measurement, but here at Yokogawa, we employ a resonant silicone, or what we prefer to call DP HARP, for the measurement of pressure. The reason, as you can see on this slide, is it has a small hysteresis, small temperature effect, and it can do multi-sensing. One of our downfalls as far as silicon resonant is that it takes a 3D micro machining, which can be very costly, but we absorb that in our engineering costs, and that way it doesn't get passed on to the customer. For those of you who are not used to the terms that are in here, an example of this hysteresis, because I get asked about, a lot of times if you're not aware, what is hysteresis and how does that happen? So a good example of hysteresis would be for when you slam pressure to one side of a DP transmitter without equalizing the low and high side. So if you were to put pressure, typically you'll have a valve manifold on this side. And when you bring in the pressure, you want to bring it in slowly and try to equalize it each side until you bring it up to full operating pressure. What happens in these types, and this is obviously the DP HARP Yokogawa, but if it was a capacitance type transmitter with a typical fill fluid, it has behind a diaphragm that's in here. If you don't equalize it, it can bend or dent that diaphragm and makes the transmitter read off. Usually you will have to re-zero the transmitter or re-span it, but still it will be damaged in the long run. On a DP HARP, such as this Yokogawa EJA 110, we use a silicon material behind it, and so it doesn't use the fill fluid. This allows it to kind of push back, if you will, if it did get slammed on one side with a different pressure and it wasn't equalized coming up. And so that allows it not to have a history or hysteresis on the sail itself. Here's an issue, as you can see here, a damaged sail, and the largest issue you'll see with these are if it saw this span, that could be from a actual process, or it could be from from slamming it over and over with pressures. And so what happens here is, as I said, it would drift off the span or the zero or change its stability. And just so you know, if you're not aware of what drift is, that's an undesired change in output over a period of time for a constant input under operating conditions. An example would be the one we used earlier, pressure being slammed on one side of a DP transmitter. And when this happens, you may have to re-zero or re-span. Or it could be just over time where the static pressure cycles go up and down on a transmitter, telling it, you know, just wearing it out over time, just like your vehicle wears out over time and under normal operating conditions. There's sometimes things like this picture you're looking at here. It can be an operational issue, such as, you know, you have someone coming on night shift bumping it with channel locks or a valve wrench all the time, and I can't legally fix that for you, but as far as the Yokogawa, as far as operation, as far as the flow of product and the process, you should never have an issue. Here is what causes a transmitter to drift or lose its stability. And hysteresis is the root cause, as we've been discussing. Many of those related symptoms of drift and loss of stability. Ambient temperature over time could affect it. The DP cycles, difference of pressures on both sides. The static pressure, I mentioned that, and overpressure events, where if you had your process was going to run at 100 pounds and you had an upset and it hit 500 pounds, and it could mess it up as far as a traditional capacitance technology. With the DP heart, the stability, or excuse me, the overpressure range is usually quite higher than what we specify, such as this transmitter is for 7,200 pounds. It actually can take an overpressure event up to 10,000 pounds. You don't want to hold it at 10,000 pounds, but it could take it for a split second there if it needed to. Here is something else Yokogawa has that is a little different, is we use the static pressure correction and temperature correction. So when you rearrange these transmitters, and we'll do that here in a minute with this one, you'll actually see that this right here, no matter what you do, the sensor is corrected with that curve, and so it doesn't make it way out of whack, and you'll keep your accuracy. So what makes Yokogawa better? Features that are just exclusive only to Yokogawa are going to be the single crystalline silicone is like elastic. There's no fatigue. There's no fatigue-like material with it, like metal sensors. A lot of these, where we talked about, we had the silicone, they'll use aluminum, and that eliminates that hysteresis we do and the drift that we discussed about earlier. We do a multi-sensing for dynamic compensation. As you can see in the middle of the slide there, we can actually, on the DP transmitter, you can extract the heart data. You can extract the internal temperature of the sensor itself. And now that will not give you, just to say this, it will not give you your actual process temperature, but it will give you the electronics temperature, what it's seeing. And actually, so you can take that multi-sensing, and that will help eliminate the variable because of drift, because you're getting the multi-sensing. Provides safety for process upsets and missequencing and manifolds. When we talked about the equalization, these transmitters can give you up to 15 years of unconditional stability guaranteed. And that makes fewer work orders in your future for transmitter maintenance, because we're recommending it, you don't have to mess with it. And if it drifts off within that 15 years, and Yokogawa will guarantee it, take care of it and fix it or get you a new one. Every transmitter that we send out comes TUV and Exida Seal 2 certified, free of charge, to meet all your customer requirements. So if you're a plant that requires Seal 2, then we can do that. You don't have to question if it's Yokogawa, it's Seal 2 rated. right here are some more talking points about our transmitters. As far as their the positive stuff about them is the majority of them come in with 100 to 1 turn down. And if you don't understand turn down is, say you had a 200 psi transmitter, and you wanted to have, and you look on your shelf that you only have a 1440 psi transmitter. You could literally range it down to 0 to 200, and it would still achieve the stated accuracy on that transmitter. And that Yokogawa has 2 tiered divisions. The transmitters on the screen is an EJX. These are an EJA. The big difference there, just so you know, is an EJA, such as these. They come with an accuracy of 0.055% of span and has a stability guarantee of 10 years. The EJX, the ones you see on the screen, they're a little lighter green, if you can tell that, versus this in the recording here. It comes with a 15-year stability guaranteed, and it can come with an option all the way down to 0.025% of span accuracy. In every transmitter box you receive, you're going to have a cal sheet, a calibration certification. And that is where the transmitter was tested before it left the Yokogawa factory. Typically, you're going to see that it will always be less accuracy stated on the spec sheet. Like this one being a 0.055, the accuracy statement that came on it was actually down to like 0 or 0.022 and when it came in. So the accuracy on that sheet is the stability typically that we're guaranteeing that to. If you keep up with that paperwork, it's always good. So calibration and setup of this transmitter, you'll find are very user friendly. Those of you who use a heart calibrator, whether it's a Yokogawa 5150 like you see on here on the screen, or whether it's 475, and you can use those to set it up. You can use FieldMate, AMS. You can use Packware, and a lot of if you download the DDs, and or in this case you can actually use a screwdriver. And if you order a transmitter with the display and the range setting on it, it's the range setting is actually free. If you order it, you just have to specify that you want it, and you can actually rearrange it. And we have 9 parameters that make it configurable, and makes it start it really easy and fast, especially you guys that get called out in the middle of the night and you want to get done as fast as you can. This is a quick way to get the unit set up. So at this time, I'm actually going to go through it, if that's okay with you guys, and I'll show you a startup. So I'm going to take I've powered this up with the 24 volts. And these transmitters, just so you know, can also come with a 4 to 20 output that has heart. We come with a brain. We come with field bus. We can get them with, we can come up with a 1 to 5. So it's typically, or it's whatever you guys have in your plant or out in the field, we can make work. So on the side of this transmitter, you'll see there's a screw. I'm going to unscrew that. Look behind it, you'll see a flathead screw right here. Kind of looks like a potentiometer, but it's not. So if you look right here on the display, you'll see a black button. And it shows your pressure right now. You can also use this to zero the transmitter. Right here, we'll go through it. There's the tag, the unit, the lower range value, and the upper. Right now it's set for 5,000, if you can see that, 5,000 PSI. I am going to range it up to the 7,200 that it can come in. All right, so I got the first digit. I'm going to press it. It's going to go to the second, to the 100 spot. I got to the 2. I'm just going to go through it, each one, the decimal, and the 10th place. You actually get it down to the 10th. Save. I'm going to press it again. And now the unit is saved, the configuration. So now we have a 0 to 7,200 PSI unit. And I can scroll through till I get back to the original. There we go. So now that pressure is it's accurate all the way up. and you don't have to set an alarm if it gets to 5,000. So you can wait till you get 7,200. As far as zero, and I mentioned, like right now, it's at 0.2 pounds it's showing. Now, to be fair, that could be because it's in this vise. It could be because I have a cap on the end. I mean, we're talking minute, right? So especially at 7,200. But if I want to, I would turn it to the left to bring it down. Oh, I went too far. I went to a negative. It's very delicate. And we'll bring it. Bring it right there after they have it on the higher side than the one. So, and we let that out. We go down to the 0. There she goes. So that's the calibration of it and the setup. Makes it real easy, and then you're actually done. And it's about that quick once you get power. Oh, went back up. So in closing, I also want you to know that 99% of all Yokogawa transmitters sold here in the U.S., they're shipped from our factories in Sugar Land, Texas, and Union, Georgia. They're not coming from Japan. And that we also want you to know, because I get asked that question a lot, and because of shipping. We here at Techstar, we keep a wide range of the products even on the shelf, including pressure and DP transmitters to help in times of plant shutdown situations where you needed it yesterday and don't have time to wait for a week or two for a transmitter to come from other places. There is not a more knowledgeable and helpful group when it comes to instrumentation than you're going to find here at Techstar. If you guys need any help, call our office at area code 281-542-0205. Or if you won't, call me. I'll get you your local rep if I'm not that person and assist you in the meantime. My number is 903-241-0099. And look me up on LinkedIn. If you want, message me there. And obviously follow Techstar on any of the social media sites you see that you're a part of. And because we do a lot of these types of training and information we like to give out. So here at Techstar, just we believe with all our hearts that we have the best products and support in this business. We would not be here if we didn't. I hope you found today's information useful. And if so, let us know how we can help by calling and emailing us for more info, or better yet, start buying Yokogawa immediately. If you don't believe Yokogawa is a better fit for you, please also let me know what we did or didn't do that led you to that decision. I'd love to have a one-on-one conversation and to understand why you think that way. I hope you all have a great week. I hope you all are keeping safe, and best of luck. Thank you.